All right, Algebra 1 students, that was a short one. Now that we're going to have one more, page 14. So if we can expand this, we're going to see that this is 2 times 2 over 2 times 2 times 2. Well, I have cancellation, and I have a 2 left over. Okay, well, I can't just call this over 2. I'm going to call it 1 over 2. So there's 1 over 2. On this one, I'm going to use my multiplication rule and add. Well, this is 2 to the 3 plus negative 2, which is really 3 minus 2. So this is 2 to the first. That's just 2. On this one, I could use my quotient rule and subtract, and I would get x to the 3 minus 5, which is x to the negative 2, right? Or let me expand it out. If I expand it, I have x times x times x, right? There's my x cubed over x times x times x times x times x. Well, I have cancellation, cancellation, cancellation. This is just 1 over x squared. So I can see that that x to the negative 2 is going to end up down there in the denominator. Well, there we are again. If I do my quotient rule, I get x to the 0 minus 4 equals x to the negative 4. Or I could use what I just learned about the 0 exponent. Anything to the 0th power is 1, so 1 over x to the 4th. See how these are equivalent? Well, I would like to write things with positive exponents, so 1 over x to the 4th is going to be my answer. So what I can see is this x to the negative m is going to go to the denominator. So I could write this as over 1. Anything can be written over 1. So this would mean 1 over x to the m. So I'm going to rephrase this in another way. I'd like to say a negative exponent flips over the fraction. All right, so let's see what that looks like. I'm going to flip all of these negative exponents over the fraction, and then I'm going to simplify them. So I'm going to bring this negative x to the negative 2 up to the numerator. So I have x cubed times x squared. It came up to my numerator, and now it's done. So now I can use my product rule, my multiplication rule, and I get x to the 5th, right? 3 plus 2. On this one, my x to the negative 3 is going to move down to the bottom, right? It flips over the fraction. So here's my fraction bar. I have x squared, and I'm going to bring my x to the negative 3 down, and now it's going to be positive. X to the positive 3. Now I can't leave my numerator alone, so I'm going to call this 1, right? So it's nothing, it's not just missing. Now let me simplify. I'm still using my multiplication rule in the denominator, so 1 over x to the 5th. Couple more. Now both of these are negative exponents, so I'm going to flip both of them over the fraction bar. That x to the negative 3 is going to go to the denominator, x to the positive 3 now in the denominator. Then my x to the negative 2 is going to go to my numerator, but it's going to become positive, x squared. All right, and if I see my cancellations, I could expand this out. Say x times x over x times x times x. Cancel, cancel, I have 1 over x. All right, if I would have subtracted from the beginning, I would have saw that this is x to the negative 1. All right, so I'm going to flip all my stuff, all my negative exponents. In this case, it's just negative 2. It's going to go to the numerator. So I got x to the 6th times x squared. That one came up from here. And then I still have y cubed over y cubed. Everything else stayed the same. Well, y cubed divided by y cubed, that's going to cancel. And then I have x to the 6th times x squared. That's going to be x to the 8th. 2 more. All right, all those negative exponents are going to go to the other side of the fraction bar. So I'm going to bring these two down to my denominator, and I get x to the 7th times y to the 5th. then these are going to come up to my numerator because they're both negative exponents. Y to the fifth times x cubed. Then I can do some cancellation. Y to the fifth divided by y to the fifth. And I have x cubed over x to the seventh. Well, this is x times x times x over x times x times x times x times x times x times x. And then I have cancel, cancel, cancel. And then I have x to the fourth. So 1 over x to the fourth. However, I don't love doing it that way. I'm going to do it a different way. This time, I'm going to use that quotient rule. So I'm going to do x to the third minus 7 equals x to the negative fourth. Well, since it's a negative exponent, I'm going to flip it to the other side of the fraction. So this is 1 over x to the fourth. And lastly, I'm going to clean up all of my 0 powers. So b is raised to the 0 power, so that is 1. C is raised to the 0th power, so that's 1. D is raised to the 0th power, so that's 1. I'm going to bring all my negative exponents to the other side. All of that with a negative 2 power is going to go to the denominator, and this 3 to the negative 1 is going to go to the denominator. So let's clean up. I have 9 still in my numerator, a squared still in my numerator. I don't need to worry about those ones. And down in my denominator, I have 3 to the positive first now, ab to the second, and c squared. Now I could do 9 divided by 3. That's just 3. A squared over ab squared c squared. Well, this is power to a power, so it's a squared b squared. 3a squared over a squared b squared c squared, and I could cancel a squared divided by a squared. Finally, I get 3 over b squared c squared. That whole giant thing just turned into that simplified. All right, hopefully that's enough so that you could do your assignment. Good luck and ask questions. I know there's a lot to this.